Hello everyone, welcome to www.MyOnlineEdu.com's video tutorial. In this video tutorial, we'll learn what are the binary numbers are, what are their applications, and how computer transform the data to binary and vice versa from binary to decimal. So let's start with what is binary data. To tell you in a simple word, computer understands only binary data. It doesn't understand what the data that we understand, which is a decimal numbers like 10, 100, thousands. These are the numbers computer doesn't understand at all. Computer understands only binary data, which are represented by either a 0 or a 1. So if you see the difference between our decimal system and the binary system is something like this. Okay, so in our decimal system, basically in our decimal system, what we do is our base is 10. Okay, so for example, a number, whatever the number we write, let's say 7, 15, it has a base of 10, right? So why 15, why 7 as a base of 10, why 15 as a base of 10? That is why this is called our decimal numbers. But in binary, it has a base of 2. Okay, so it has a base of 2, and that is why this is represented by only 0 and 1. So any number, it cannot have anything else other than 0 or 1. Similar to our decimal number, it has a range of 0 to 9. So any number that can only have 0 to 9. For example, 15. See, it has 1 and 5 in it. Right? So a given number cannot have anything other than 0 and 9. That is called the decimal numbers. Similarly, in binary, it cannot have anything else other than 0 and 1. So how does a binary number looks like? It's simple. It's a normal number. For example, if you write 1 0 0 0 1 0 1 1, so this data represents a binary number. Okay, so as there is no other digit other than 0 and 1, that is why this is called a binary data, and computer understands only the binary data. So now we know what a binary data is. So let's take the measurements of the binary data. So you know that a bit is basically a bit that can store only 0 and 1, and a byte is a 8-bit, a kilobyte is a 1024 bytes, and 1 megabyte, which is a MB, is called 1024 kilobytes. So here what happens is a particular digit is called a bit. For example, this one is called a bit. Let me change this one. Okay, so a particular digit is called a bit. This is called a bit, and then 8-bit data represents a byte. So here we have 1 2 3 4 5 6 7 8. So whole this thing 8-bit data calls a byte. So we can say 1 byte is equal to 8 bits, right? So this whole data is called byte. Okay, Similarly, like when you are measuring the data in kilobyte, so 1024 bytes represents 1 kilobyte. Similarly, 1024 kilobyte represents 1 megabyte. And that is how 1 gigabyte, 1 terabyte, those are calculated. But these are the basic stuff that you should understand. Now, when you see this particular thing, since binary data represents 0 and 1, so 0 is called the off bit and 1 is called the on bit. You can imagine this thing as a switch. Like if the switch is on, that means it represents 1. If a switch is off, that means it represents 0. Okay, so now you must be wondering, how can I correlate the binary data with our decimal data? So the thing is, this data 100001011, actually it represents a decimal number which is 139. Now let's see how that representation happens. How computer understand that this binary data represents to 139 as a decimal number. Okay, so now we'll go through the binary to integer conversion. Excuse me. So as you can see that so I'll show you the technique how actually you can convert the binary data to an decimal integer decimal. So the technique is very simple. What you do here is, once you write the binary data in this form, once you write the binary data in this form, from the rightmost bit, which is this one, you put a 0 on top of it. Okay, you put a 0 on top of it, and then 1, then 2, then 3, then 4, then 5, then 6, and then 7, and this goes on. Since it's 8-bit data, so it will stop here at 7. So 0 to 7, it represents 8-bit data. Now what you have to do is, you have to write 1 into 2 to the power 7, okay, plus, again this bit is 0, so 0 into 2 to the power 6, plus, again this bit is 0, so 0 into 2 to the power 5, plus, again this bit is 0, so 0 plus 2 to the power 0 into 2 to the power 4, plus, now this bit is 1, so 1 into 2 to the power 3, plus, this bit is 0, so 0 into 2 to the power 2, plus, this bit is 1, so 1 into 2 to the power 1, plus, this bit is 1, so 1 into 2 to the power 0. If you look at here, this particular calculation is done for a particular bit. So this one is what? The bit value. Here the bit value is 1, that is why this 1 is here. And into 2 to the power 7, what 7 represents is the bit number. Here is a 7. Similarly, this particular bit calculation for this particular bit, right? And then the value is 0, and into 2 to the power 6. 6 is the bit index. We call it index. Okay, so 0 is the bit value into 2 to the power 6. So if you are calculating for a particular bit, then it's a bit value into 2 to the power bit index. So this is the normal representation to calculate a particular bit. So we got this particular string like this here, and then if we calculate, we got 127. Anything into 0 is 0, anything into 0 is 0, anything into 0 is 0. Then 1 into 2 to the power 3 is 8. Then anything multiplied with 0 is 0. Then 1 into 2 to the power 1 is 2, and then 1 into 2 to the power 0 is 1. So if we add this sum, we got a number 139. So this is how the binary to integer or a decimal conversion is being done. Okay. So once you know this technique, now you can definitely go for an easy way. I am telling you an easy way. Okay, this is the normal technique, but here I am showing you the more easiest technique. What you can do is you can write down the number like this. Okay, you can write down the number like this, and then from the rightmost bit you can start putting 1, then 2, then 4, then 8, 16, 32, 64, 128. So first you start with 1, then you multiply it by 2, which you got 2, then you again multiply by 2, 2 into 2 is 4, then again you multiply by 2, you got it 8, put 8 over here, again you multiply by 2, you got 16, again you multiply by 2, you got 32, 16 into 2 32, and then again you multiply by 2, you got 64, again you multiply by 2, you got 128. Okay, so now once you put this particular numbers over here on top of that your actual binary numbers, it can continue. If it has more bits over here in the left side, over here you can continue, like it will be then 256, then it will be 512, like that, next bit. So now you add the numbers you got here, for the 1, which bit represents 1 only. So the bit represented by 1 is this one, and then this one, and this one. That is why you are adding this 4 bits which consist a value of 1. We ignore zeros, okay, because anything into 0 is 0, so that is why we don't consider 0. Okay, so we consider only the bit value 1, and then we add them, and we got a final value which is 139. So this is a little bit shortcut. You don't have to do lot many multiplications, 2 to the power something, those calculations you don't have to do, but this is a shortcut way. But this method actually coming from the earlier method that I have shown you before. So that's the way that you do the from binary to decimal conversion. Now we are going to the other way around. We have a decimal number, and how computer changes it to binary number which it understands. Okay, so if I tell 139 to computer, it doesn't understand anything. It doesn't understand 139 as a decimal number. But if computer changes it, basically computer changes it number to 100001011 to understand that, okay, this is the representation of the binary of decimal value 139. Okay, so the process is this: to convert from a base 10, which is a decimal integer number, to its base value 2, which is a binary equivalent, the number is divided by 2, and the remainder is the least significant bit. Okay, and the integer results is again divided by 2, and its remainder is the least significant bit. This process repeats until the quotient becomes 0. So we will go through the example now. Okay, so what is happening here is I'm sorry, what is happening here is we divide the decimal value, which is 139, by 2. So we got a quotient of 69 and remainder as a 1. So this is our least significant bit. Okay, now again in our next step we put the 69 here and divide it by 2. We got a 34 as a quotient and remainder as 1. Then again we put this in the next step. 34 divided by 2, we got 17 and remainder as 0. Again we put 17 divided by 2, we got 8 as a quotient, 1 as a remainder. Okay, and then put 8 again in our next step. We are doing the same step, we are repeating the same step, but only the quotient is coming into our operation in our next step. Remember that. So we got 4 as a quotient and then 0 as a remainder, right? So then again 4 is coming to the next step, and then we got a 2 as a quotient and 0 as a remainder, and then put 2 divided by 2, we got 1 as a quotient, 0 as a remainder, then we put 1 as an operation, then 1 divided by 2, we know that quotient is 0 and the remainder is 1. So here we stop because we got a quotient which is 0 now. Okay, and then we read the data from top to bottom in this direction. Okay, and then we put it something like this. So this one is coming here as a 1, then this one will be coming here as another 1. Okay, so this 0 will be coming here as another 0. So this one is coming as a 1, so this 0 is coming as a 0, then again another 0, another 0, and another 1. So this is our data. So 1 0 0 0 1 0 1 1. Okay, so this is how you convert it to a binary number. So that is how the things are done. Thank you for watching this video tutorial. I hope you liked it. If you liked it, please subscribe to our channel, and also you can visit www.MyOnlineEdu.com and you can avail the courses that are available. The courses are very competitively priced and they are instructor led courses. So there will be a particular instructor like me who will be teaching you all these things. If you want to learn C programming, data structure and all this stuff, we provide them. Thank you for watching. Have a good day.